All right, so on the front side of this, we were talking about combinations. Now on the back side, we're going to talk about permutations. And if you remember from earlier, there's a big difference between combinations and permutations. And you need to be able to identify whether it's a combination or a permutation. And the way we do that is by thinking about order. When we talk about order for a permutation, the big difference between a combination and a permutation is in a combination, the order does not matter. But in a permutation, the order does matter. So that means, order does matter. What that means is if order matters, we should be doing the permutation stuff. If order does not matter, we should be doing combinations. So, for example of a permutation, 10 people, there are 10 people racing. Well, if there are 10 people racing, the order does matter because you can finish in different places. So order matters because finishing first, second, third, so on and so forth matters, because if I finish first, I'm doing better, and if this were a track meet, I would actually get more points for my team to help my team win. So when we talk about this, the order really does matter. So that means the order that we're choosing the people from, so order chosen, determines the place. In other words, the place that you finish in. So in this case, order does matter, because if I chose the person first, we would say they were finishing first. If I choose them second, they're finishing second. So order matters, which means that this is a permutation and not a combination. Okay, so since order matters, that means that we're going to have to do things a little bit differently. Since order matters, our first step is to make blanks based on the number of the subset that is chosen. So for example, normally you only get points in track for the first, second, and third place person. So I would do 3 different blanks because those are the numbers that I'm choosing. Those are the number of subsets that I'm choosing in order to get points from them. Then after that, we're going to fill in the first blank with the number of elements. What I mean by that is this. How many different options do I have for someone to finish first? Well, because there are 10 people in the race, I have 10 different people to choose from, so I have 10 different options for my first place person. Then the next blank is one less than that. Is one less because one element was already chosen. One element was already chosen. So what I mean by that is this. If I chose my first place person, then I really only have 9 people left that can possibly finish in second. And now that I've chose a first and a second place person, there are really only 8 people that are left to choose for third place. So then that means that the next blank is one less, and so on. And then you would multiply the numbers to get your answer. To get number of possibilities. Number of possible combination, or number of possible arrangements. Okay, so this one would be 10 times 9 is 90. And 90 times 8 is 720. So there'd be 720 total possibilities for possible ways for people to 720 possible ways for 10 people to finish first, second, and third. All right, so now let's look at the actual example. In how many different ways can 10 students be chosen from 603 to be valedictorian, salutatorian, and so on? So in this case, finishing first versus finishing second, and so on, matters, because if I get chose first, then I'm the valedictorian, and that's better than being the salutatorian, which is better than being the third highest in the class, so on and so forth. So in this case, order matters, because I want to be chose first, because I want to be that valedictorian, which makes this a permutation. If order matters, it's a permutation. If not, it's a combination. So I'm going to be choosing 10 students. So if I'm going to be choosing 10 students, that means there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 slots that I have to fill. And we start out with 603 total. So there's 603 people that could be the valedictorian, but once they're chosen, there's only 602 to be the salutatorian. There's only 601 to be the third, 600 to be the fourth, 599, 598, 597, 596, 595, 594. And now I'm going to multiply those together to find the number of possible combinations for the top 10 people to be chosen to be the top of their class. So, I need to move that up a little so that I can see. So, 603 times 602 times 601 times 600 times 599 times 598 times 597 times 596 times 595 times 594. So this one is one of those scientific notation ones. So, because I'm viewing it like this, I'm going to only go a few after the decimal. So 5.896 times 10 to the 27th ways. Now we could write this out the long way, right, which means I'd have to move this over 27 times, but that would be a really long number, so I'm okay with you leaving that in scientific notation. All right, but just like with combinations, permutations also have a shortcut to type it in the calculator, and you might have noticed it when we were in there last time. The button looked like this. It was N, and instead of C for combinations, then it's P, R. So we're going to want to get to this in the calculator. Just like before, that N still stands for the total number of elements. So my first step is to, because my first thing that I see is going to be an N, that means my first step is to type in the number of elements. Because the N still means the same thing as before. So for example, let's use this one, right? Let's use this one over to the side. There were 603 valedictorians. So 603 was my number. Then it's going to be P, right? So I'm going to have to get to getting to that P. So in my calculator, I'm going to clear this out, type in 603. Just like before, we're going to press the math button, right? The math button, which is underneath the alpha button. Scroll over to probability. Now instead of choosing the C for combinations, we're choosing the P for permutations. So in order to get there, we did math. We went over to PRB for probability. And then we selected the NPR. So 603 was the total number. And remember that the R is going to be the number chosen. So the next thing we do, we type in chosen subset, which is your R, right? So in this case, I was choosing, so this is my N, my total number was 603. I was choosing 10, so that's my R. So then we type in that next. So 603, NPR 10, and we get that same number, 5.896. E means times 10 to the 27th. Okay? Oh, and I forgot, you had to press enter. All right, so let's read through the next one together. In how many ways can 23 students be ranked by ability? So if I'm ranking you by ability, don't you want to be chosen first so you are the most able? So in this case, order matters. And since order matters, we make it a permutation. Okay, now in this case, right, it's NPR, right, where N was the total number of elements. So my total number of elements is 23. P, and then ranked by ability. So it doesn't say we're choosing a specific amount. Since it doesn't say a specific amount, no specific number chosen means use all. So in this case, we're going to rank all 23. So it's going to be 23, P23. So we're going to go to our calculator. We're going to type in the 23, math, go over to the permutation and choose 23 is this number here, which is 2.585 times 10 to the 22nd. Oops, that doesn't really look like a 10. Times 10 to the 22nd. And like I said, since that would be a huge number, I'm perfectly okay with you leaving that in that notation. Now, because it matters whether or not you can identify if it's a permutation, combination, or neither, that's what we're going to focus on here. Which one is it? And these instructions are important. Find out which one it is and calculate the number of arrangements. We're going to do a few of these together, and then you're going to try others on your own. So let's look at number 1. 4 students are walking into class. How many different ways could they arrange themselves in a front to back pattern? So you see how they're talking about how many different ways can they arrange themselves? In general, I would normally think it doesn't matter. I get in the class when I get in the class, but they say they are arranging themselves front to back pattern. So this tells me that the order does matter, because they want to know the number of patterns based on the order that they're standing in, which makes this a permutation. Okay, so my first answer would be that this is a permutation. And then we need to do NPR, right? So 4 students are walking into the classroom. That tells me that 4 is the total number, and we're arranging them all back to front, so 4P4. So then we have to go to our calculator, right? And type that in. So 4 math 4. So I got 24 as my answer. Okay, let's read the next one. So, checking out 3 library books from a list of 8 to help you prepare for the AP Euro exam. So, if we're looking at this, we're checking out 3 library books from a list of 8. So, does it matter which order I check them out in? The answer is no, because no matter which order I check them out in, I'm still going to get those same 3 books. So, the order does not matter. Order does not matter, which means that this is a combination. So we can say this is a combination. So the total, so it's NC now for combination R. So the total number of options is 8, because that's how many we have in total to choose from, and we're only going to choose 3. So then we go through that process again, right? We're going to do 8 of them, and then we go over to the probability, and now I'm choosing the combination, and then we're choosing 3 of those, which tells me there's 56 different combinations of those 3 books from a selection of 8. Last one, the number of ways to answer 15 true or false questions. So when I look at this, there are 15 true or false questions. Isn't each one separate? So there are like 15 different things and I have 2 options to do this from, so I can either pick true or false, and they're all separate, right? They're all separate options. So really, I'm just doing 2 times itself 15 times. So this is actually a neither, because it's not like we're selecting some from a list of options. It really is that there are 2 options for each one. So this really is counting, basic counting, and I'm doing 2 times itself 15 times because there's 15 true or false questions. And 2 to the 15th power is 32,768. Okay, so now you're going to go ahead and you're going to try 4, 5, and 6 on your own. And those we're going to check tomorrow in class. So remember to identify permutation, combination, or general counting, and what would you do with it.